Hello, I will present Beyond RGB, a real-world dataset for multispectral imaging in mobile devices. This work was done with our team in Samsung Israel R&D Center and Samsung Korea Institute of Advanced Technology. We introduced a diverse and large-scale dataset of RGB and multispectral images for mobile devices with both a color chart and an illumination measurement. The dataset is suitable for luminance spectral estimation, color constancy, and color accuracy tasks, among others. Beyond RGB contains more than 1,500 scenes, of which around 500 are collected in the field and around 1,200 are collected with an automated viewing booth. Each scene was captured once with a color chart and once without a color chart, with Android mobile RGB camera and with a multispectral camera. Here you can see examples from our dataset. In the top row, there are sample scenes captured in a viewing booth. The second and third rows are sample scenes captured in the field in indoor locations, and the last row shows sample scenes captured in the field in outdoor locations. In column B, you can see the counterpart samples of images 5, 10, 15, and 20 captured without the color chart. In column C, you can see the corresponding multispectral image cubes, and column D shows the ground truth illuminance spectrum measurements of these scenes. The RGB images are captured simultaneously with the multispectral images to ensure that the same scene is viewed in both images. For the multispectral images, we use a prototype camera with 16 distinct filters arranged in a 4x4 color filter array. We provide the multispectral data as an HDF5 file in the native resolution with minimal post-processing. For reference RGB cameras, we utilize two widely available flagship Android phones. We furnish the original raw image data as an HDF5 file along with the corresponding metadata. Here you can see a comparison of our dataset to existing datasets. There are a few hyperspectral and spectral reflectance datasets, but our dataset stands out due to its extensive size and diverse range of scenes, encompassing posed, indoor, and outdoor scenarios featuring moving objects. It incorporates ground truth colorimetric references and measures illuminance spectra. Our data contains scenes taken in a wide variety of illuminance. Our lab illuminants provide good coverage of the Planckian locus and also include some heavily tinted illuminance off of the locus. The real-world images authentically capture illumination phenomena and provide a wide cover of different times of the day and locations. As an example for the usage of our dataset, we developed an illumination spectral estimation algorithm. The model consists of dividing the multispectral image into triplets of 3 channels, processing each triplet by the well-known CCC block, and then converting the CCC block output to spectrum. Our model utilizes both the color chart ground truth and the illumination measurement. We surpass state-of-the-art results on established benchmarks and set a baseline performance on our own dataset. In addition, we utilize the presence of RGB data from different devices in our dataset and demonstrate a simple extension of our proposed method to include RGB and multispectral data, showing the power of fusing multispectral and RGB images and the potential of cross-camera research with our dataset. Thank you for your attention.